I am T. Kavita, Assistant Professor of Mathematics, Department of BCA. Today's topic is relations. What is a relation? Relation is a relation describes a connection between elements of two sets. If A and B are two sets, a relation R from A to B is a subset of A cross B. A cross B is a Cartesian product of the two sets A and B. R is a relation. Therefore, R is a subset of, a relation is a subset of A cross B. Examples of a relation. Let A is equal to 1, 2, 3 and B is equal to 4, 5. A has 3 elements and B has 2 elements. Now we define R is equal to 1, 4, 2, 5, 3, 4. The arrow diagram, image of 1 is 4, image of 2 is 5 and 3 is 4. 1 and 4 have the same images 4 and 2 have the image 5. This is the arrow diagram and 1, 2, 3 and 4, 5. A is a domain, B is a codomain. Relation R is defined as 1, 4, 2, 5 and 3, 4. Next, we are going to see the types of relations. Reflexive relation, symmetric relation, antisymmetric relation, transitive relation and equivalence relation. First, we are going to see the reflexive relation. A relation R on a set A is reflexive if A, A belongs to R for all A belongs to A. The element is related to the same element is called a reflexive relation. Example, a relation R is equal to 1, 1, 2, 2, 3, 3. The diagram loops off on each element. Next relation is a symmetric relation. R is a symmetric if A, B belongs to R implies B, A belongs to R. That means if an element relates to A relates to B, then B is also relates to A. This is the these two sets are belongs to that set. That relation is a symmetric. Example, R is equal to 1, 2 and 2, 1. The diagram is 1 if and only if 2. Next, antisymmetric relation. Antisymmetric relation is if A, B and B, A belongs to R, that means A equal to B. That means if the element A relates to B and B relates to A, then the two elements are same. A is equal to B. If example R is equal to 1, 1, 2, 2 and 1, 2. The diagram is one-way arrow unless A is equal to B. The next relation is a transitive relation. That means if A, B belongs to R and B, C belongs to R, that implies A, C belongs to R. That means if in R, A relates to B and B relates to C, then automatically A relates to C. It's happened in only transitive relation. Example, 1, 2. Relation R is equal to 1, 2, 2, 3. 1 related to and 2 related to 3 and 1 is also related to 3. This is the diagram 1 to 2, 2 to 3 and 1 implies 3. This is the transitive relation. Next relation is equivalence relation. What is the equivalence relation? A relation that is reflexive, symmetry and transitive, it's called an equivalence relation. A relation satisfies reflexive relation, symmetric and transitive, then the relation is equivalence relation. Example, same remainder 1 divided by 3. This is the equivalence relation. Equivalence classes are equivalence of 0, 3, 6, 9. It is divisible by 3. And equivalence class of 1 is equal to 1, 4, 7 and 2 is equal to 2, 5, 8. The real life examples. Real life examples is a symmetric relation is friend of, equivalence relation is equal to, and reflexive, antisymmetric, transitive. That means equivalence relation is subset of. This is the real life examples. Our conclusion is relation describe connections between elements of sets. Relations describes connections between elements of sets. Understanding relation properties helps classify relations. Understanding relation properties help classify relations. That is used in the relations are used in algebra, computer science, graph theory, and etc. Thank you.